Hello everyone, welcome to another video on integration, and I'm still busy with techniques of integration. To be specific, the u-Substitution, and I'm evaluating indefinite integrals. All right, so our first integral for today is the integral of 3 open brackets x minus 5 to the power 7 dx. If you notice, if you try to expand this, you're going to make a mess of it, and so u-Substitution comes in handy on this one. So let's look at how the solution is set out for this one. Answer for question 1, let me copy the integral as it is, the integral of 3 x minus 5 to the power 7 dx. And I'm going to immediately say let u be equal to x minus 5, differentiating u with respect to x, du dx is equal to 1 because the derivative of x is 1, and the derivative of minus 5 is 0 because minus 5 is a constant. Multiply both sides by dx, you're going to get du is equal to dx. And therefore this integral changes to the integral of 3. Remember that will be u to the power 7, and then du. 3 is a constant, so it can come out the integral of u to the power 7 du. And so the law of differentiation, basically the inverse operation of differentiation, is actually integration. So I'm going to add 1 there and then divide the result into the expression. So this will be 3 u to the power 8 all over 8 plus c. So you add 1 and then divide. Right. So getting back to our original variable, which is x, the connection between x and u is that u equals x minus 5. So this can be rewritten as 3 over 8, and then I have x minus 5 to the power 8 plus c. That's my final solution. Remember, for all indefinite integrals, we always add a constant there, c. So this is our final solution to our first integral, which is this one here. Right. Let's move on to our second integral for today. Our second integral is this one here, the integral of cos cubed of x sine x dx. And again here we're gonna let cos x be equal to u and then carry on. So our second solution or second integral is the integral of cos cubed x sine x dx. And if we rewrite this, it's gonna look like this: cos of x cubed sine x dx. And if we let u be equal to cos x, remember the derivative of u with respect to x in this case is going to be minus sine x. Derivative of cosine is minus sine x. Cosine x, derivative of cosine x is minus sine x. Multiply by dx both sides, you're going to get du equals minus sine x dx. Now if you look at this one here, is that one there, but there's no minus here, so this minus must go. And how do we get rid of it? Well, we divide both sides by minus, so you're going to have minus du equals sine x dx. So this integral then changes to the integral of u cubed. In place of sine x dx, I'm going to put minus du there. Take the minus out, it's minus the integral of u cubed du. And this simplifies to minus u to the power 4 over 4, obviously plus c, because we're dealing with indefinite integrals. But remember, our u is cosine of x. That's our u. That's the relationship between u and x. So this must be minus a quarter of cosine of 4x plus c. That's our final solution to this integral right there. That's our final solution, right, to our integral number 2. Let's move on to the third integral. So the third integral for today is this one. There is our third integral. We're supposed to integrate or evaluate the integral of e to the power 2 sine x cos x dx. Again, when you have a power, most In most cases, you have to let the power be equal to u. So in this case, number 3, we're going to say the integral of e to the power 2 sine x cos x dx. We're going to let u be equal to 2 sine x, and then differentiate u with respect to x. This is going to be 2 cos x. Remember, the derivative of sine x is cos x. Now multiply by dx both sides. You're going to get du equals 2 cos x dx. If I look at this part here and that part there, the 2 must go. So we have du over 2 is equal to cos x dx. Now this is exactly equal to that one there. So it means in that place I must put du over 2, and in that place I'll put u. So this integral then changes to the integral of e to the u, and what we have, du over 2. And half is a constant, it must come out. So half the integral of e power u du. And the integral of e power u is just e power u, so this is half e power u, and obviously we have to say plus c because we're dealing with indefinite integrals. Now what is the connection between u and our original variable is that u is equal to 2 sine x. So this must go back to our original variable, which is half e to the power 2 sine x and then plus c. So this is our final solution to our integral number 3. Right, let's move on to our integral number 4 for today. Our integral number 4 for today is this one. This is our integral number 4 for today. Right, we're supposed to evaluate the integral of sine of natural log of x over 2x dx. Right, so let's capture this as quickly as we can. Number 4, we are saying the integral of sine of natural log of x all over 2x dx. I'm going to rewrite this. 2, remember half is a constant, it must come out, and then I'm going to have sine of natural log of x, and then I'm going to say times dx over x. Remember, the 2 and the x are dividing, so I can write it like this. At this stage, I'm going to let u be equal to natural log of x, and therefore du over dx, in other words du dx, is actually equal to 1 over x. Remember the differentiation of log functions, right? Multiply both sides by dx, you're going to get du is equal to 1 over x dx, and remember this is just dx over x, and this expression here is that expression there. So in that place I'll put du, and here I have sine u. So this integral then changes to half the integral of sine u du, and that's what I have. Remember, dx is equal to this. I mean, du equals dx over x. That would be du sine u, and then the half is out. What is the integral of sine u? Is minus cos u. So this is half minus cos u. Of course, we're dealing with indefinite integrals. So this finally changes to minus half. But what is u? U is natural log of x. So this will be cos of natural log of x. We use absolute value there plus c. And that's our final solution to integral number 4. Right, let's move to integral number 5. Our integral number 5 for today is this one here. This is our integral number 5. We're supposed to evaluate this integral, the integral of cos 3x all over e to the power sine 3x dx. So let's go right into it. Number 5, integral number 5. We're just done with integral number 4. Now we're starting with integral number 5. Let me capture it exactly how it is. Cos 3x all over e to the power sine 3x dx. I'm going to rewrite this to, check this out, cos of 3x. I'm going to put dx right at the top, and I'm going to say all over e to the power sine of, check this out, sine of 3x. Now at this stage I'm going to let u be equal to sine of 3x, and therefore du dx is going to be equal to, remember we differentiate sine first, which is cosine, and of course we have 3x, and then multiply by the derivative of 3x, which is 3. Multiply by dx both sides, du is equal to 3 cos of 3x dx. And if you look at the top part there, we have cos 3x dx and not 3. So this 3 must go. So we have du over 3 equals cos of 3x dx. Now this is exactly what you have at the top there. So therefore this integral changes to the integral of du over 3 all over, in the denominator we have e to the power u. Now we have to rewrite this integral as follows. Rewriting this integral, we're gonna take the 1/3 out, and we're gonna take the e to the power u up. So this integral changes to 1 over 3, the integral of e to the power minus u du. And the integral of e to the power minus u is actually minus e to the power minus u. And then we have to say plus c because we're dealing with indefinite integrals. Now what is u? U is, if you check, go back to our original variable, u is actually sine 3x. So this will change to, if I come back here like this, right, it will change to 1 over 3 e to the say times e to the power minus sine of 3x, like so, plus c. And let's rewrite this expression, because remember that's minus e to the power minus u is sine 3x, like I showed you. So rewriting this, we're going to get, this is minus 1 over 3 e to the power minus sine of 3x, and then plus c as our final solution. Right, this is the final solution to integral number 5, which is basically this. Our solution is that one. Right, let us move now to integral number 6. We have 2 more to go, number 6 and number 7. Integral number 6 for today is this one. We're supposed to integrate or evaluate this integral, of course using u-substitution. Moving forward, number 6, integral number 6, it says the integral of 2 all over x natural log of x dx. I'm going to rewrite this to 2 out, the integral of 1 over natural log of x multiplied by dx over x. Remember, the x and natural log of x are dividing. At this stage, I'm going to let u be equal to natural log of x, and therefore du dx equals 1 over x. Multiply both sides by dx. You're going to have du is equal to, remember, multiply this by dx is just dx over x. And this expression is that expression there. So I'm going to have du there, 1 over u, and then 2 outside. So this integral then changes to 2, the integral of 1 over u, remember, and then I must have du. What is the integral of 1 over u? Well, natural log of u. So this is 2 natural log of u plus c. Now what is u? Well, u is natural log of x. So there I must have natural log of x. So my final solution is 2 natural log of x, like so, plus c. That's my final solution to our integral number 6. Right, let's move on to integral number 7, which is our last integral. Integral number 7, last integral in this video. There it is. Now we are supposed to evaluate the integral of e to the x. Remember, there is minus there. It has to be clear. E to the x minus e to the minus x over e to the x plus e to the minus x dx. Right, let's go straight into the work. Let me capture the integral as it is. The integral of e to the x minus e to the minus x all over e to the x plus e to the minus x dx. Now I'm going to rewrite this integral to the following. So this is going to be, check this, 1 all over e to the x plus e to the minus x times, and I'm going to put this in brackets, e to the x minus e to the minus x dx, like this. And then at this stage, I'm going to let u be equal to e to the x plus e to the minus x, this part here. Differentiate u with respect to x, du dx, du dx, not very clear there, right? Du dx is going to be equal to, remember, derivative of u of e to the power x is e to the power x. Derivative of e to the minus x is minus e to the minus x, like that. All right, minus e to the minus x, and then multiply both sides by dx. You're going to get du equals e to the x minus e to the minus x in brackets dx, and this expression is exactly that one. So I'm going to have 1 over u, because e to the x plus e minus x is u, and then du. So that integral then changes to the integral of 1 over u and then du. What is the integral of 1 over u? Well, natural log of u. Natural log of u plus c. Now, notice something. What is u? Is e to the x plus e to the minus x. This can never be negative. So it's not necessary for us to put absolute value signs there. So this is just going to be natural log of e to the x plus e to the minus x, and then we're going to say plus c. That's our final solution. Right? This is where I'm going to end in this video. If you're new to the channel, please subscribe and support us by sharing these videos, liking them and sharing them, and please give us feedback. We would greatly appreciate your feedback. It will help us restructure our videos to reach and help as many students as we can. All right, God bless you. See you in the next one.